Alright everyone, apologies for not being there with you guys today. I promise I'll see you guys again soon. This is the video lesson for Wednesday, January 20th, Concept 15, Solving Quadratics by Factoring. If you guys recall, last week we did a bit of review on graphs and quadratics, and then the focus was on factoring quadratics. So all the factoring types and techniques to being able to factor a quadratic. So why did we review all the factoring of quadratics? Because concept 15, as you guys can see here, right, we're going to have to solve these equations, these quadratic equations now, using the factoring techniques. So a couple things I want us to make note first are the steps to being able to approach this. So first step is, it's the important one, is move all terms. Okay, move all terms to one side and set equal to 0. Okay. Super important idea. This is something that's going to come up a lot in our class next year in pre-cal and in your college math class, college algebra. Solving quadratics is a recurring skill or concept that comes up a lot, and oftentimes I've found that when I ask students, we're going to solve this quadratic, what should I do? Students don't tend to realize, or they just forget that they're supposed to get a quadratic equation equal to 0 to be able to solve it. Okay, so very important first step. Step 2 is factor. Step 3 is set each factor. So here's where it's gonna be. There's gonna be some review here. Set each factor equal to 0 and solve for each x value. Also, before I forget, okay, make sure you do the attendance survey. I know I'm out, but still the attendance survey is something that needs to be completed for the school, so be sure to do it. Password is coffee. Okay, and then write your answers as, we'll just write it as x is equal to something, x is equal to something, okay? Like this. So, let's look at the examples then. And this concept is very similar to last week's. Again, we're just being a bit more intentional. Okay, we got to solve this quadratic equation right here. So first step is to make sure all your terms are on one side and it's equal to 0. It already is. I don't have to do it for step 1. So then I can just go ahead and factor. Now notice, right, if you guys recall last week I said always check to see if you can do a greatest common factor. Okay, and when I look at this equation here, there is, right? I only have 2 terms out of this quadratic equation. Normally there's 3, right? But this one only has the first 2, and this is x squared and this is 9x, so then I can factor out an x. And when I do that, I get this right here, right? If I distribute this x back in, I get the original. So then that's pretty much it. Now what you want to do is set each factor equal to 0 and solve. So this first factor, this x outside, set him equal to 0, and then the parentheses, x plus 9, set him equal to 0. And so then you solve each of these, right? And notice that the first one, it's already solved. It's just x is equal to 0. Right here, you'll subtract 9. And the second x is equal to negative 9. Okay? What I want you guys to remember is graphically, what does this mean, right? What does it mean to solve a quadratic? So if you guys remember, last week we did a little bit about graphing, right? When we would graph quadratics to solve them. Okay, what does it mean to solve a quadratic? It means of course you found the x values, but what specifically is happening at these x values? You are intersecting the x-axis. Okay, so this quadratic equation right here hits the x-axis, the parabola, right? It's going to cross the x-axis at x is equal to 0 and at x is equal to -9. Okay, very important connection that a lot of students miss. Okay, that's what we're doing here in these equations without having to look at the graph at all. Okay, so here's example 2. First step is move all the terms, make sure it's equal to 0, and yes it is. I don't have to do that step. So then I'm going to go ahead and factor, and first thing is check if there's a greatest common factor, and then you'll notice, oh wait a minute, right, once again I only have the first two terms, right? I don't have the third term in a quadratic equation. So then let's check if you can do a greatest common factor. 4 and 8, I can pull out a 4. X squared and x, I can pull out an x. So then I'll get x, 4 times what is -8? X minus 2, close parentheses, that's equal to 0. So then now set each factor equal to 0. So 4x is equal to 0, and x minus 2 is equal to 0. This first one, to solve for x, divide both sides by 4. Right? 0 divided by 4 is 0. So x is 0. And right here, if I add 2 to both sides, I get x is equal to 2. Okay? And that's all there is to it. So again, what's happening when you find these answers here? What are you solving for? This quadratic, when you graph it, the parabola is going to be crossing the x-axis at x is equal to 0 and x is equal to 2. Okay? That's what's happening. Next one, and that's what pretty much today's lesson is about. We will be looking at various examples of quadratic equations and how to factor and solve them. You'll notice this one, right? I don't need to do step 1. Everything's already equal to 0. X squared minus 4, only 2 terms again, right? But there's a difference between this example to the previous 2 we did. That second term does not have an x, right? This means this is the third term in our usual form, right? A quadratic equation, if you guys recall, is ax squared plus bx plus c, right? So these first 2 examples had the ax squared plus bx terms, but this third example has definitely the ax squared term, right? But it has only the c for the second term. Okay, so then that means it's definitely not going to be like this factoring right here. And it's 2 terms. You might or hopefully recognize x squared is a perfect square. 4 is a perfect square. So then this one right here is a difference of squares. Remember, this is the one where you got 2 parentheses, plus, minus, square factor of x squared, x and x, square factor of 4, 2, and 2. Set each of these equal to 0 and solve. X is equal to -2, right? Subtract 2 from both sides. And this one here, add 2 to both sides. X is equal to 2. So -2 and 2. Okay? For this one, notice again, right? I got 2 terms only. Okay, I got 2 terms only. And I also have only the ax squared term and the c term, right? So it might be a difference of squares again. And 9 is a perfect square, 25 is a perfect square. I am subtracting, right? And x squared is of course a perfect square. So yes, this is a difference of squares again. Okay, square factor of 9 is 3. Sorry guys. Square factor of x squared is x and x, plus minus square factor of 25 is 5 and 5. So then set each of these factors equal to 0, and then you solve. So first thing here is I got to subtract 5. Okay, so I'll get 3x is equal to negative 5. Then I'll divide by 3. So then x is equal to negative 5 over 3. So sometimes your answers will be fractions, and that's okay. On the right side here, very similar, but instead I'll be adding 5 to both sides, then dividing by 3, and so x is 5/3. Okay? Okay, next I got x squared minus 10x plus 21 is equal to 0. Notice that this quadratic equation is a trinomial, right? I got all three terms here. So then this is the one we do with the x. Factors of 21 that add up to negative 10. So what two numbers multiply to 21 but add up to negative 10? That'll be negative 7 and negative 3. So then this will be x minus 7 and x minus 3. That's equal to 0. Set each factor equal to 0. And if I solve each of these, right here add 7, right here you add 3. Okay, here are my two solutions. Let's see, number 6, this is a good one. So you guys can see, right, I think so far we have what, 3, yeah, it looks like 3 out of the 4 sets on the factoring review from last week. So here I have a quadratic trinomial. All the terms are on one side, it's equal to 0. Okay, remember, first thing you want to check is, can you do a greatest common factor? Okay, I didn't do it on this step, okay, on this problem, but I should have. Okay, but a quick check, right? Notice that the leading coefficient is not 1 like it is here, right? I have a 2. So remember, what you want to check is there a greatest common factor? Can I factor out a 2 from everything? And you notice that, well, I got 2, 2, and 24. So then yes, you could factor out a 2 from everything. 2 times x squared is 2x squared. 2 times negative x will be negative 2x. And then 2 times what is negative 24? Negative 12. Okay, this trinomial in here, the one inside the parentheses, that's the one that we can factor out. Factors of negative 12 that add up to negative 1. So what two numbers multiply to negative 12 that will add up to negative 1? I'm thinking negative 4 and 3. Okay, so then I still add that 2 there. Okay, x minus 4 and then x plus 3. Now when you have just a number like this outside the parentheses, notice that in number 1, right, we had an x outside the parentheses, and so x was just equal to 0. Okay, right here we had a 4x equal to 0, so 4x is equal to 0, and then we got 0. But right here there is no x, it's just a 2. Okay, so when you have a case like this, you ignore it. Okay, you don't have to worry about him. Why? Because, well, is 2 equal to 0? No, right? So again, completely ignored. You only worry then about the factors that you have in the parentheses. So then your first one here, right, add 4 to both sides, so your answer is positive 4. Right here you'll subtract 3 from both sides, so then your answer is negative 3. Okay, so we'll do a few more examples and then call it a lesson. Let's see, I think this is a good one. Okay, 3x squared minus 13x minus 30. So remember, the first thing you want to do is make sure everything's equal to 0, and it is, right? Next is factor, and you'll notice that the leading coefficient here is 3. So then your next step would be, well, check if you can do a greatest common factor. Now, can you pull out a 3 from all 3 terms? Well, the first one, duh, right? That's the 3. Can you pull out a 3 from 13? Right? 13 is prime, so no, you actually can't pull out a 3 from 13. So then you're stuck. So then this is the one, if you guys remember, this is the final set we did last week, where you take the leading coefficient and you multiply it with the last number. So this would be x squared minus 13x minus 90. Okay? So then yes, I'm going to be looking for factors of negative 90 that add up to negative 13. Now when the numbers are big like this, it's going to take you a little bit to think. Okay? Again, best bet is to just use Google, right? I would Google what are factors of 90, and then when you get that list of numbers, then just, you know, work with the positive and the minuses to see if you can get 2 to add up to be negative 13. And when you do that, you would find that negative 18 and 5 work. Negative 18 times 5 is 90, negative 90. Okay, and negative 18 plus 5 is negative 13. So then this would be x minus 18 and x plus 5. But don't forget, this is the step students forget, right? You got to undo that multiplication in the beginning by dividing both constants by that number you multiplied by, 3. Okay? The first factor then becomes x minus 6. But the second factor, 5 does not divide 3. So remember, all you got to do is just move it to the front of that. Make it a coefficient. Okay? There. Now you can solve each of these factors. The first one, x minus 6 is equal to 0. And then the second one, 3x plus 5 is equal to 0. For this one, just add 6 to both sides. So x is equal to 6 is an answer. Right here, you would subtract 5 from both sides. And then you would divide by 3. Okay? So that's how you would approach this one. Oops, I put number 9. Sorry guys. Number 8. Let's look at this one. So finally, here's a quadratic equation or a problem, right, where it's not equal to 0. So then this is what that first step meant in our first page here. Move all terms to one side and set it equal to 0. Okay? So what you got to do then is you got to subtract 5x from both sides. Okay? And what that will do, now you can rewrite it like this. Okay? So there's an extra first step, in other words. So now I can go ahead and proceed by solving this quadratic. And notice there's only 2 terms, right? And it's the first 2 terms, the ax squared and the bx. Okay, so then maybe I can just factor out a greatest common factor and go from there. I have a 2 and a 5, so no, I can't factor out a number, but it looks like I can factor out an x. So if I do that, that'll be x, so then 2x minus 5 inside. And that's pretty much it. I think from here, right, x is equal to 0, and 2x minus 5 is equal to 0. First one's done, nothing you can do there. For the second one, I can add 5 to both sides, and then divide by 2. Okay? Good. And remember, what are you doing when you're solving these quadratics? You are finding where the parabola crosses the x-axis. If you graph this quadratic, right, all these quadratics we've solved so far, that's where they would be crossing the x-axis. Okay? Okay, next one. And it looks like for these we're just, well, it looks like we're just faced with that extra step. We got to move everything to the left side. So don't forget to do like terms, right? Notice this time there's two values on the right side, so not only do I have to subtract the x squared, and notice that I'm going to subtract it to this first one here because he's the one with the x squared. That's the like term. Okay, but I'm also going to use green for this one. Add 1 to both sides. Okay, so then again, this guy and this guy will cancel, and this guy and this guy will cancel. 2x squared minus x squared, that's just x squared. Negative 50 plus 1, you owe someone $50, you give them $1, you still owe them $49, and everything canceled out on the right side. Okay, you got two terms, right? Notice he doesn't have an x, you are subtracting, and yes, 49 is a perfect square. X squared is a perfect square. So this right here is actually just a difference of squares. Plus minus square factor of x squared, x and x, square factor of 49, 7 and 7. Set each of those equal to 0. You get negative 7 and positive 7. Okay. Couple more. Feel free to pause the video if you have to take a quick break, right? I mean, probably just hearing me all the time might make you a bit sleepy. Go grab a snack or something, chew on something. So first thing, by looking at this, right, I'm gonna have to move over that 80. Right, it's not equal to 0, so I'm going to have to subtract 80 to both sides. And then also notice, right, that, well, 80 is not a like term with either of these guys, right? This has an x squared, this has an x. So then I'm going to get x squared plus 2x minus 80. I guess I didn't make an emphasis for number 8, right? Number 8, when I subtracted 5x from both sides, right, x squared and x, these were not like terms, so then I put them together like this. Okay, anyway, so here we are. So I need factors of negative 80 that add up to positive 2. And again, when the numbers get this big, just Google it. Okay, don't overthink it, just Google it. You might you know, be able to see it easier from there. Sorry guys, I got distracted. Okay, but the factors of negative 80 that add up to 2 would be negative 10 and positive 8. They multiply to negative 80 and add up to 2. So then x minus 10 and x plus 8 are equal to 0. Set each of these equal to 0, and so then add 10 to both sides. There's one answer. Subtract 8 from both sides. There's the other answer. Okay, we'll do 2 more here, and that will wrap up our lesson. Here's what we have, right? So I got to pass everything over to the left side. So I am going to subtract x squared from both sides. And notice where I'm subtracting it, right? Again, these are the like terms, okay? So those will cancel there. And then I also got to add x to both sides. And that right there, the negative 9x, that's the like term with that one. And so then 2x squared minus x squared, that's just x squared, Negative 9x plus x, that's negative 8x. Then negative 65, that's equal to 0. So this is it. This is the one that, right, the graphic organizer, factors of negative 65 that add up to negative 8. Okay, again, use Google, power Google to see what the factors are of this number. Okay, and then go from there. I'm getting negative 13 and 5. Okay, those multiply to negative 65 and they add up to negative 8. So then x minus 13 and x plus 5 is equal to 0. Set each of these equal to 0. Add 13 to both sides. Subtract 5 from both sides. And there you go. Okay, last example. We'll wrap it up with this one. Okay, so I got to pass these two over to the left side, but notice that the left side I have an x squared. So when I subtract x from both sides, right, they'll cancel out there, but these are not like terms. They're not, okay? One's an x squared, one's an x. Also, if I add 21 to both sides, again, 21 is not a like term with the 2x squared. So then what you got to do then is just write it all out like that, okay? Because they were not like terms. And of course everything canceled out on the right side. You'll notice, right, I have a trinomial, 3 terms, okay? And then the leading coefficient here is 2. So then you want to check, okay, can I factor out a 2 from everything? And then you'll realize, no, I can't. So then this is one of those trinomials where you take the leading coefficient and multiply with the constant. You get x squared minus x. 21 times 2 is 42. Factors of 42 that add up to negative 1. I'm getting negative 7 and 6. They multiplied to did I do this wrong? Yes, I did. I had positive 21 in the original equation. I wasn't supposed to add 21, right? I was supposed to subtract 21 from both sides, right? Because it was plus 21. Sorry guys, apologize. So this right here should actually be a minus. So 2 times negative 21 will be negative 42. There you go. So now it works. Okay, they multiply to negative 42 and add up to negative 1. So this will be x minus 7 and x plus 6 is equal to 0. Don't forget to undo the multiplication. Divide your constants by that number you multiplied by. The first term here does not divide, right? So then 2x minus 7. 6 divided by 2 does though. So x plus 3. Boom, there you go. So then I'm running out of space here. This factor right here, let me see, where can I go? I'll just flip it sideways. So then 2x minus 7 is equal to 0, and x plus 3 is equal to 0. This guy right here, just subtract 3 from both sides and you're done. So x is negative 3. And right here, if I add 7 to both sides, and then if I divide by 2 both sides, 7 over 2. Okay, and there you go. Key takeaway, remember, is that all these answers you are finding, again, graphically, they mean if you put this quadratic in the graphing calculator, you'll see that it crosses the x-axis at those x values, okay, the ones you are finding. Okay, that's what's happening in this lesson. Alright guys, good. Thanks for listening, and you'll submit notes on this video here, and then on Friday is a regular math day, right? Friday I will assign you your IXL on this lesson. Okay, see you guys.